Now in 8.2, we're going to start looking at operations and compound inequalities as well as sets. Now, Venn created what we call the Venn diagram. What we see here, let's call a group. So you guys see an oval. Let's call A. Anything in A is an element as part of group A. We also see group B. Anything inside that oval is part of group B. However, there is a section, you guys see it, we shaded. It's a section that is shaded, it's used in both groups. Now that's what we call the intersection. And the symbol we're going to use for intersection, it looks like a U upside down or an N. So let's take a look at this. Let A be the groups 1, 2, 3, 4, and let B the numbers 2, 4, 6. Now we want the intersection of A and B. So which numbers are in both sets? I'm going to say the number 2 and the number 4. Now let's take a look at inequalities. When we have two inequalities, when we're going to have an intersection, we're going to have the word and. So let's take a look at this thing. Let me solve the first inequality. I'm going to subtract 1 on each side. So I get x is less than or equal to 8. I can easily graph that one. I'm going to graph it in a minute. Looking at the other, if I added 2 to each side, I get x is greater or equal to 5. I see my numbers are 5 and 8. So let me label my graph as I need to. Let me call this 5. Let me call this 8. Now I'm graphing as I need to because it's not, I'm numbering it, I'm labeling it as I need to. If it was already labeled, that would be better. So looking at the first inequality, it looks like a bracket at 8 and it goes towards the left. Looking at my other inequality, it looks like a bracket at 5 and it goes towards the right. Now, because I'm using the word and, that's basically intersection, I'm asking which numbers or what part is it in both graphs? We can see it goes from 5 to 8, brackets on both, and everything in between. That's my graph. Now, if they ask you for the interval notation, how far left do we go on the graph? We go as far left as 5. How far right do we go? We go as far right as 8. Let's take a look at another example. I'm gonna bring the negative as a positive 2 to the right. So I have negative 3x is greater than 7. Divide both sides by a negative 3. I'm dividing by negative. So x is less than negative 7/3, or we call that negative 2 and 1/3. Okay, I can graph that one. Looking at the other one, let me add 1 to begin with. So I have 5x is less than or equal to negative 20. Let me divide by 5. So we get that x is less than or equal to negative 4. My answer is a negative 4, but I'm not going to flip the arrow. Oh, I forgot to. I'm not going to flip my arrow because technically I divided by a positive. Now here, my numbers here, I'm going to label them negative 2. I'm going to go here, negative 2 and negative 3. Okay, I can easily graph that one. So that means this right here is negative 4. Negative 2 and 1/3, it's a parentheses, and it's about here and goes to the left. Negative 4 is a bracket, and this one also goes to the left. So I'm asking, what is in both graphs? Both of them. I have a -4, a bracket, and goes to the left. That's my graph. Now, interval notation. How far left do I go? I go as far as -infinity. How far right do I go? Keep in mind, I'm looking at what is in both graphs. So how far right do I go? I go as far right as a -4. My -4 has a bracket. Now we're going to see what we call union. Now, union is an element, so a part of the group that it is at least in one of them. It doesn't have to be in both, at least in one of them. So let A be the numbers 1, 2, 3, and 4. Let B be the numbers 2, 4, and 6. So find A union B. So I'm looking at the numbers that are at least in one of the sets, and I'm going to say the numbers 1, 2, 3, 4, and 6. Now be very careful on your notation. Don't try to shortcut as saying the numbers 1 through 4 and 6. Don't do that, because once you say the numbers 1 through 4, you are including everything in between 1 and 4. That means you're also including decimals. So do not shorten it like that. It's just that. Now, let's graph this. The union, we're going to usually do it with the word or. We're going to see in a minute what we get. So let me solve the first inequality. Let me bring the 2x over as a minus 2x. Let me bring the -4 as a plus 4. So I get 4x is less than 4. That means x is less than 1. Okay, can do that one easily. Take a look at the second inequality. Let me divide both of these by a -3. Dividing by a negative. So x is greater or equal to 3. Right, I flip my arrow because I divided by negative. So let me label my numbers as I need to. There's 1 and there's 3. So the first inequality, it's a parentheses at 1 and it goes to the left. The second inequality, it's a parenthesis, it's a bracket at 3 and I go to the right. So my graph, I actually have to include both of them. Because remember, I'm asking which one is in at least one of them. So I have to include both. Now, when it comes to interval notation, I'm going to ask how far left do I go? I go as far left as -infinity and then 1. And then I also have from 3 to positive infinity. Infinities are always parentheses. Now the other numbers, 1 and 3, you guys can see where I got the parentheses and where I got the bracket from.